Hello, everybody. How's it going? Sorry if I interrupted any previous discussions that were happening. We are going to get started about now. We have about 23 people here. And let me make sure that I get the speakers on screen. So Alexander, Colin, and Peter, if you click the camera on and mic on, then you will come up on screen. All right.
Hi, everyone.
Hello.
Hello.
Awesome. So it's a pleasure to have everyone here today. We're just going to get started. I just want to tell everyone what the Blockchain Acceleration Foundation is, and then I will pass it on to Colin. So in short, the Blockchain Acceleration Foundation, also known as BAF, the 501c3 nonprofit organization that starts accredited classes at universities and provides recruiting and research opportunities for our members. We host these weekly meetups where we bring in different protocols and try to get students engaging with really awesome companies like Near. And we've had some pretty great companies in the past. We have a lot of cool events in the future. The next event is going to be with the founder of Bitcoin and a founder of Panvala. It's going to be a part of this San Francisco Decentralized Governance meetup group that I also co-run. And super excited about that. And before handing it off to Colin, I wanted to highlight that we recently joined forces with She256, which is another 501c3 nonprofit focused on bringing more diversity in the blockchain space. And I want to make sure that everyone on this call can complete this type form really quickly, because they're conducting this really awesome research to identify the better ways to get more women and underrepresented minorities in the space. And they are awesome, and that's one thing. The second thing is the event next week. Also, in the morning next Wednesday, we're hosting an event with the organization in blockchain education organization in Africa, all about the state of blockchain education development and adoption in Africa. So we'll drop those links in the chat. But Colin, I'll let you take it away from here.
Yeah, thanks, Cameron. So without further ado, I'll introduce Alex and Peter, two members of the Near team. Alex previously worked at MSQL as director of engineering, is now the co-founder of Near. And then Peter is the head of development at Near. They're going to be introducing us to sharding, explaining what they're doing at Near relating to sharding, and then followed up by some questions and a Q&A from the audience. Without further ado, Near is a decentralized application. It's meant to manage high-value assets like money and other, identity goods. It's trying to power open finance and open web. Brief intro of that, and then I'll hand off to you guys to talk about sharding.
Okay. Hi, everyone. And thanks. Thank you guys for having us, and thanks, Colin, for the intro. Let me start sharing screen. So I will briefly talk about sharding. I will talk about sharding in the context of Near. Sharding can be built in multiple ways, and those ways have certain differences, but the challenges that arise from building sharding are the same, and the benefits are also sort of the same. So let's start. So first of all, why do we need sharding? Why sharding is a useful approach to scalability. In general, when you think about scalability of blockchains, there are multiple reasons why blockchains are slow. One big reason, for example, why Bitcoin and Ethereum are slow is because specifically for the longest chain consensus they use, it is necessary that the block propagation time is significantly smaller than the block time. It is less so in Ethereum with Ghost, but it is the case for Bitcoin. So majority of time, the network is actually idle. That can be solved, and sharding is quite orthogonal to that. So we will assume that problem is solved, and that the blockchain can operate practically at the speed, or at least within the order, like on the same order of magnitude as the speed of executing the transactions. Once we get to that, there are two ways we can make blockchain to be faster. One way is we can make every machine that operates blockchain still continue processing every transaction, but do that faster. And the second way we can do that is we can separate the load and make every machine that operates the blockchain only process a subset of transactions, right? So the former approach is taken by many blockchains today, by majority of them, as a matter of fact, which are besides maybe Near, Ethereum 2.0, and a couple others who do build sharding. That approach very quickly hits certain limits. I guess one of the biggest limit it hits is storage. If you think about blockchain, which is used by the population of, or like by decent percentage of the population of the planet, it is unlikely that the entire state fits in memory. The state becomes pretty large. Majority of transactions, let's say if those payment transactions or transfers, etc., they cannot be using in-memory caches. They start hitting disk, and disk is relatively slow, and all of those are random reads. And modern SSDs like Samsung 960 are pretty fast, but still that is a pretty large bottleneck. And moreover, it imposes a certain requirements for the nodes that operate the blockchain, right? So the state of the Ethereum today, and Ethereum is by no means fast or captures the large percentage of the population of the planet, but the state is already, I guess, on the order of 200 gigabytes, right? So if we want to capture, if we want to execute larger TPS, if we want to capture larger audience, easily the state can reach a terabyte and beyond. That means that nobody who has a terabyte to spare on their disk can operate the blockchain, right? So sharding solves all those problems by separating the compute and state into multiple shards, where every shard is a logical representation of the part of the state and all the transactions that execute against that state. And most frequent way of building sharding is by also having a separate blockchain on every shard, right? So if we have a whole account space, we will separate into some number of shards, let's say into 10, and then we'll be just operating 10 blockchains, where every blockchain is responsible for 1/10 of the entire state and for processing transactions that affect it. Near does not work the same way. The primary reason is because the shards, and we will get to that once we start diving deeper into the details, but shards generally do not live in isolation. If the shards were living in isolation, it would be no different from just 10 independent blockchains. They need to communicate. And if you have 10 separate blockchains with 10 separate fork tree rules and 10 separate consensuses, that would be way more complex to orchestrate them. So instead, the way Near works, and I will be using the screen share. There's a full screen button, so if it becomes too small, click it. The way Near works is there's exactly one blockchain. We call it main chain or the chain. There's only one chain. There's no shard chains. There's no beacon chain. So there's no confusion per se. And logically, every block, even though the state is separated into multiple shards, logically, every block still contains transactions for all the shards, right? So if this is block A, this is block B, this is block C, 3 consecutive blocks. Block A will logically contain all the transactions that against all the shards at that particular point in time. Block B will contain all the transactions for all the shards at that point of time, and block C will contain all the transactions for all the shards in the third block. Now, physically, that would be unfeasible, assuming a heavy load. So let's say every shard can process like on the order of 2,000 transactions per second. So every shard at every block contains 2,000 transactions, and there's, let's say, 100 shards. That's 200,000 transactions. So it is infeasible even to download them at that speed. So physically, instead of containing all those transactions are separated into so-called chunks. And every block for every shard contains 0 or 1 chunks. So let's say there are 4 shards. If there are 4 shards, then block A will physically, all the transactions that exist on block A will be physically split into 4 chunks. So let's say for now that every shard does have the chunk corresponding. And then the first chunk will contain all the transactions for the first shard. The second chunk will contain all the transactions for the second shard, the third for the third shard, and the fourth for the first shard. It could be that the chunk is skipped, right? So if the corresponding actor in the system who was supposed to produce the chunk at that particular time frame is offline or lagging, the chunk would be skipped. So at the next height, it could be that shards 1, 3, and 4 do have chunks, but the second doesn't. So that just means that at that particular moment, when B is produced, there's no transactions. And also, the particular consensus that NEAR uses is it's a flavor of BFT consensus. It's extremely simple, and it's similar to Tendermint and hot stuff and PBFT and all consensus in that family, with the difference that it's pipelined. It's similar to hot stuff in this regard, and therefore, when block A is produced, it's only when the block C is produced that A is final, and that allows producing blocks twice as fast. So if you're familiar with Tendermint or PBFT, and you know that they have pre-vote, pre-commit, pre-vote, pre-commit, so effectively at each of those, there will be a block dropped in NEAR, right? So pre-vote for one phase, pre-commit for another is a block, right? So if block A is proposed, then B is a pre-vote for A, and C is a pre-vote for B and a pre-commit for A. And that allows blocks to be produced more frequently, approximately once per second. And that in turn makes it not as big of a deal if a chunk is skipped, right? So if a chunk is skipped at one height and then it is included in another, that means that there's 2 seconds instead of 1 second latency, which is acceptable. So the chunks are no actor in the system unless they actually want to validate all the shards and they ready to have hardware capable of doing that. Will be downloading all the chunks. Instead, what the block physically contains is the headers of the chunks. And so when we fetch the block, we see the header of every chunk for every shard. And then if the particular shard is of interest to us, we will download the chunk. And so if someone does want to validate all the shards, they will download all the chunks. For them, the blockchain will be no different from non-sharded, but they will have to run extremely expensive hardware, most likely with multiple SSD drives, each assigned to separate shard. For most actors, they will be validating one or very few shards. And so they will be downloading a very cheap block which only contains headers. And then once they know the header, they will fetch from the network the chunk. So let's consider a particular actor who only tracks shard number 1. Right, so they do not track any other shard. And so therefore, when they download every block, they only download the chunk for shard 1. They see transactions for shard 1. They execute them. They maintain the state for shard 1. They don't care at all what happens in another shards. That works great until there is some sort of communication between shards, right? So if there's a certain transaction, let's say Alice wants to pay Bob, and Alice lives in one shard, Bob lives in another, without loss of generality. Let's say Bob is actually living on shard 1. Then the transaction needs to hit both shards. So it will first hit shard number whatever, where Alice lives. And once that happens, somehow the second part of the transaction needs to be transferred to the first shard. So we call it a receipt. A receipt is effectively the same as a transaction, with the difference that if transaction is authenticated by signature of the user who submits it, a receipt is authenticated by effectively the participants of the particular shard attesting that they executed the previous step of the transaction and the second step is correct, and they're sending it to the first shard. All right, so effectively, if somewhere here, there was a first part of the transaction of Alice sending money to Bob, and then somewhere between block A and block B, a receipt from third shard to first will be sent, and the participants of the first shard will execute the receipt. Now, the problem is that because very few participants in expectation are validating every shard, it is significantly cheaper to corrupt a particular shard than to corrupt the entire network. And so what malicious actors will do is they can go to all the participants of shard 3, which is only a small subset of all the participants, and they can adaptively go to them, pay them something that covers their stake on or any other associated costs, get their keys, create some invalid state transition, mint a lot of money, and use cross-shard transactions to send it to other shards. A particular person who validates the first shard will have no insight into that, right? They download blocks. The blocks do not contain transactions themselves. They download the first chunk in every block, and the transaction associated with it, they have no way of detecting that shard 3 was corrupted and invalid state transition was committed. And a very common solution to this problem is we can say, well, but someone is validating shard 3. So even if the adversary managed to corrupt every single block producer in the shard, it is unlikely that they would be able to corrupt every single participant who observes it, right? There are people in the world who just run full nodes or like nodes for a particular shard, and they just see the transactions. And so what we say, if that node observes that there's a chunk with an invalid state transition, it is obviously can be cryptographically proven. There's no rocket science there. like for example, if the way optimistic rollups work is exactly the same way on Ethereum. They just submit a challenge and they say a particular state transition in a particular chunk was incorrect. And they send it through the network, and if whichever participant validates the first shard only receives the challenge, which proves cryptographically that there was an invalid state transition in one of the previous blocks in one of the other shards, they will just unroll the chain up until before that moment. Right, so let's say block A was produced, block B was produced, block C was produced and received by a particular participant who only validates shard 1, and then they receive a challenge which says, as of block A, there's an invalid state transition in shard 3. So what the participant who just applied block C will do is they will unroll their chain as of before block A, and so their head will be the block before A. So a couple important things that happen here. A is that that means the transactions are atomic, right? So the second part, so if this chunk was invalid and there was an invalid state transition and there was some action taken on it in another shard, that gets unrolled naturally together with the actual offending transaction. So that is something that is harder to do when there are multiple chains, where multiple chains need to be simultaneously unrolled back. And this presents, I guess, one of the hardest problems in sharding that were actively being researched last year, which is called the problem of data availability, which is if the adversary actually managed to corrupt the entirety of the shard 3, and they created an invalid state transition, notice that at no point the adversary actually has to share the entire chunk for the system to continue operating and invalid state transition to take effect. Specifically, the block itself only contains the header, the chunk header, which contains potentially the state root or receipts root that other participants use. And the participant who only tracks shard 1, when they download the block, they see the header of the chunk in the third shard. They somehow receive the receipt. They can validate the receipt is valid against the header. At no point they actually observe the chunk. And so all the participants in the network which maintain the blockchain, except for those who are in shard 3, never need to download the chunk for shard 3 to continue operating. And so by the time they produce block C, it could be that the chunk for shard 3 was never actually published. Only the header was published. And if the chunk is not published, you cannot prepare the challenge. To prepare the challenge, you need to know the transactions. You need to be able to execute them. So that's called data availability problem. And it, in this form or in slightly different forms, it applies to any sharded network. It applies to any optimistic or ZK rollup. Right. So, for example, Optimism, which builds optimistic rollups, they have the same data availability problem. They solve it by submitting all the transactions to Ethereum cold data. For example, StarkX, which runs 3,000 transactions per second, their data availability is using a centralized set of entities. So there are 7, I think, entities, including Starkware itself, Inclusion, and a couple others, who attest that data is available. So if they collude, data becomes unavailable and funds get frozen. Cool. So with that being said, let's actually dive into how it all works, how we solve data availability, how we implement cross-shard transactions, etc. For that, let me move below. So I have here a small diagram. On this diagram, time is the x-axis. So from left to right is from earliest to latest. And let's say there are 8 participants in the network total. So those are block producers. So the lifetime of Near blockchain is split into epochs. Every epoch is approximately half a day. And within half a day, the set of block producers is fixed. And so the block producers are responsible for producing blocks and for producing chunks for executing transactions, for maintaining the network. And so green lines here are just a logical separation into shards. So let's say there's 4 shards, and every shard has 2 block producers assigned to it. So P1 and P2, they're validating shard 1 and producing blocks. P3 and P4 are validating and producing blocks for shard 2. 5 and 6 produce and validate for shard 3, etc. It could be that there are more nodes in the network that validate every shard, but these particular participants are assigned specifically to produce the chunks and to produce the blocks. They all take turns producing blocks. And so let's say, and so yellow lines are, it's approximate moment in time when the new block is about to start getting produced. And so let's say before we get into the first time frame, let's say P2 was responsible for producing blocks. And there was a block produced. And so let's say this is height, some height. I will be using some particular numbers just because it's easier. So let's say this was height 7. And so we're moving to produce a block at height 8. So when P2 produces block, the block, as a reminder, the block is a very small entity. It's just the headers of the chunks. So it's usually relatively small. The block gets broadcast to all the participants. And so every participant receives the block. And once every participant receives the block, they download the chunks that they need. And we go through the process of downloading chunks at the next time frame. And once they have all the chunks they need, they apply transactions and they accept the block. Once they accepted the block, they start producing chunks for the next height. And in every shard, at every height, there is a particular block producer who is assigned to produce the chunk. So let's say that at this particular height, at height 8, P1 is assigned in shard 1, P3 is assigned in shard 2, P5 in shard 3, and P7 in shard 4. And so once they apply the block from height 7, they start producing chunks. And so locally, they will get transactions from the mempool. They will collect them into a chunk. They will produce a chunk. So I will be using chunk as a square with like a little corner to distinguish from blocks. Okay. So once the chunk is produced, chunk contains certain information. First of all, chunk contains the previous block hash. So if this is the block at height 7, it has certain hash. Every chunk that is built for the block 8 contains in itself the hash of the block at height 7, and that chunk can only be included in the block which immediately follows. Then they contain the previous state root, so they contain the state root as of before the transactions in the block are applied. This is the reason why it includes the previous state root and not the post state root. We're not going to go too deep into it. It's unrelated to sharding. In general, when you build blockchains, you can choose either or. When you use previous state root, you will get higher throughput but slightly worse latency. If you use post state root like Ethereum does, you will get lower throughput, better latency. We use previous state root. It contains transaction root, and it actually the chunk itself contains transactions. So when the chunk is produced, the chunk is not broadcast. Instead, it does something different. What it does is, so let's say that the total number of block producers is n, and we say n is equal to some 3f plus 1, or rather like less equal. So in our case, n is equal to 8. So af is equal to 3. Okay, it's actually greater equal. And f is equal to 2. So what the participant does when they produce the chunk, so let's consider this particular chunk in the shard number. I actually don't know when I do screen share if my mouse is visible, but let's consider this particular chunk in the shard 3. So what P5 does when they create a chunk is that they split it into f parts. And also 2 is too small number, so let's also consider a more practical case when n is equal to 100, and so f is equal to 33. So in this case, P5 will split the chunk into 33 parts of equal size, and then they will erasure code it to get to n parts, to n shares, such that any f shares are sufficient to reconstruct. And then every share, so these 100 shares here. Let's see. So this chunk is split into one. Oh, this is huge. It's split into 100 shares. So every share is assigned to a particular block producer. And so first share is specifically assigned to the first block producer, second share specifically assigned to the second, etc. And so then every share is sent to the block producer with that corresponding ordinal. And so here, if we somehow know that at least 2f plus 1 of them attest that they received their shares, and we assume that less or equal to f of them are deviating from the protocol, we know that the chunk is available. I don't know if it makes sense why, but but it's simple arithmetic, right? So if 2f plus 1 attest that they have data available, less than f deviate from the protocol, that means at least f plus 1 do have data that they have locally and they're ready to share. And that means everyone can as long as they continue serving this data, everyone can fetch those f+1 parts and reconstruct the entire chunk. Right, cool. So once that is done, the block producer for the next height, so in this case, because for the previous height it was P2, let's say P3 is producing block for the new height. For some time, the block producer accumulates these shares, right? So they received share of the chunk that P5 created. Also P3 also erasure coded their chunk and sent it out, and well, I guess they obviously received their own share. P1 also erasure coded their chunk and send their share to everybody, including P3. And so P3 for some time accumulates those shares, and then at some point they create the block. And so the block will create the block will contain chunks for which P3 themselves have the shares, right? So obviously that is not sufficient for data availability, right? Data is only available with reasonable certainty if 2f+1 of block producers attest that they have their shares. When the block is produced, only one participant so far attests, so the block might actually have unavailable data. However, on the next iteration, for P4 to produce the block, they will need to collect approvals on the block that is produced by P3 at the height 8 from 2f+1 participants. And so the block itself, the valid block at height 8, must contain the approvals from 2f+1 block producers on the block at height 7. The block on height 9 must contain approvals from 2f+1 block producers sorry, at height 8. And so, give me 1 second to grab water. Sorry for the interruption. Good speakers obviously prepare in advance. I'm still learning. Cool. So let's continue. When the block at height 8 is produced, the block producer, each block producer. So on the figure here I have 8. When the block is broadcast, when each of them receives the block, before they accept it, before they append it to their blockchain, they first, for every single chunk included in the block, wait or attempt to fetch their share of that chunk, right? So optimistically, by that time they will have their share, because when every chunk was produced, the shares were immediately sent to the corresponding block producers. So they were being sent out concurrently with the block production, right? So optimistically, and usually it is the case, by the time the block is received, the block producer either already has the chunk, or the chunk arrives to them within a very short period of time, the chunk share. But sometimes the chunk share might not arrive. For example, the chunk producer was malicious and did not send it to begin with, or the network message got dropped, or whatever. So then they request it, right? And if they cannot request it from a particular participant, they start requesting it from others. And so for every chunk, not only for the chunks in the shards that we track. So for example, P1 only tracks shard 1, but for every chunk in every shard, a participant needs to have their share before they accept the block, and therefore before they send the approval. And so this is what guarantees data availability, that by the time block at height 9 is produced, it must contain the approvals from 2f+1 participants. Each of those 2f+1 participants, at least the honest among them, and there's at least f+1 honest among them by assumption, only send the approval after accepting the block, and they only accepted the block after they had their share for every single chunk in it. And so therefore, for every chunk in the block at height 8, at least f+1 of honest participants that follow the protocol have their share of that chunk and ready to serve it. And so therefore, data is available, and we can be sure that if the chunk is invalid, everybody will be able to download it and validate. Cool. So P1 specifically, besides downloading their share for every chunk, for the shard that they track, shard 1 specifically, they also need to reconstruct the whole chunk because they need to apply it, right? So immediately after the block is received, they will they will also try to fetch every share, or at least f+1 shares, specifically for the chunk in shard 1. And also this is done in a more optimistic way. Specifically, every block producer, once they receive, so let's use P5 as an example instead of P1 because we have the chunk drawn out, right? So when P5 produces the chunk and sends it out to every block producer, when they receive their shares of the chunk, they know that P6 will need those shares to make progress, to apply the chunk. And so they immediately, optimistically send those shares to P6, right? And so again, if everything goes well, P6 will have the entire chunk by the time they receive the block that contains the chunk or shortly after, right? And so because of those optimistic, and if you think about the timeline of networking, right? So between the block at height 7 and the block at height 8, it takes three messages, right? So the block is sent, that's one message. And it's not a round trip, it's just a single direction message. Once the block is received and the chunk is created, the chunk part sent from P5 to every block producer. This is the second message in a single direction. And then every participant sends the message further to P6, that's the third message. So every block, from the network perspective, the block is bounded by three single unidirectional messages. And in practice, it is possible to send 3 messages in 1 second, even if the people are globally distributed. The latency of the longest hop is usually around 300 milliseconds. So it could be slightly slower. Cool. So that addresses data availability. I don't know how we're doing in time. Shall we also cover cross-shard transactions, or shall we conclude here?
I think now would be a good time for Colin to come back on and ask some questions, and then we'll move to audience Q&A. But thank you, Andrew. That was really good.
Sounds good.
Yeah, thank you so much. So I have a couple general questions about sharding, and then some more just about the Near protocol and Near overall. So I was hoping maybe you could explain a little bit about cross-shard verification. I know there's different approaches to it, and maybe just briefly explain what it is.
Right. Okay, so that was the next thing I was going to tell about anyway. And it fits very well to this. So everything I described so far, there is no cross-shard communication yet, right? So I described how the chunks are created with transactions specific to the chunk, and then they sent out. So as we execute the transactions, as the particular block producer executes transactions in the shard they track, some transactions might create receipts which need to go to another shard. So the specific way it is implemented is when they finish executing transactions and when they package them into the chunk, they know the receipts that need to go to other shards. And so the chunk itself, the header of the chunk contains the Merkle root of those receipts. And these little messages that send the shares of the chunk also contain the receipts which are relevant to the specific recipient of the share, right? So when P5 sends the erasure-coded shares of the chunk to, for example, P3, P5 is very well aware that P3 is a block producer who's tracking shard number 2, right? And so they can include all the receipts which originated in shard 3 in that particular chunk and are destined to be in shard 2, and include the Merkle proofs, right? So when P3 receives that message that includes those receipts, they can validate the following statements. Statement number 1 is that receipt actually corresponds to the Merkle root of the receipts that is in the chunk header, right? They can just verify the Merkle proof, which is attached to, obviously Merkle proof is attached to the message, right? Second, they can immediately confirm that the Merkle root in the header corresponds to the header itself is included in the block, right? The block contains chunk headers. And the block also, the hash of the block depends on all the chunk headers. So the hash of the block indirectly contains the attestation to the particular receipt, right? So receipt validates against the Merkle proof. Merkle proof is in the chunk header validates against the hash of the block, right? So as long as this block is valid, meaning that every chunk in it is valid, the P3 knows that the receipt is valid. Why receipt could be invalid? Receipt could be invalid if the state transition applying transactions in the chunk that P5 created actually does not result in creation of that receipt, right? So for example, no transaction in P5 sends money to Bob, but there is a receipt that is sent to P3 that says, give more money to Bob. But because that receipt validates against the hash in the chunk, that means that the hash in the chunk, the receipt hash, does not correspond to the same receipt if someone independently executed the same chunk, right? So therefore, whenever any external observer executes the same chunk, they will not arrive to the same set of receipts, and therefore the hash of the receipts will be different, the Merkle root. And so that is a slashable condition. That means that the state transition is applied incorrectly. They can generate a challenge, send the challenge to the network. Everybody in the network can validate it, right? So therefore, if P3 receives a receipt, they can safely assume that for as long as block 8 remains on the chain, so it is not challenged, that receipt is valid, and so they can safely execute the receipt, right? And so also there's a question in the chat how the participants are assigned for shards. So there's a randomness beacon, which is right now it's very simplistic. Right now every block producer has exactly 1 bit of bias, but we do have a completely unbiasable randomness beacon implemented. We're not going to be shipping it in the next several months. We need to test it further. But 1 bit of influence is very little, so that is for shuffling of block producers. And so therefore, when the epoch switch happens, the randomness beacon output is used to random shuffle all the block producers and assign them to shards. So assignment is random.
Thank you. Yeah, that was a great explanation of that. Another question relating to sharding. Maybe on a general scale, could you maybe explain? I mean, it's very, like, I guess, well known, at least for me, that there's certain, inherent security concerns of sharding. Could you maybe explain how, like, Near is mitigating those, and just how you handle that?
So we already discussed most of the particular concerns, right? So the concern is that in a non-sharded blockchain, every participant validates all the transactions, right? And so it is inherently impossible to create a block with invalid state transition which will be respected by anyone. So you can effectively assume that the block with invalid state transition cannot exist, while in sharding they can exist because not everybody validates all the transactions. And so that needs to be mitigated. So in this regard, if anyone is familiar with the concept of a optimistic rollup, right, you can think of Near as a lot of optimistic rollups with data availability being solved the way I just described.
Okay, I see. Yeah, that's generally a good generalization of it. Moving away from sharding a little bit and more to just more general Near focus. Could you maybe explain, like, some of your future plans for the governance of Near? I know from a little bit of reading, I've heard, like, I know the Near Foundation's kind of control of development and the governance, but I've heard, the main focus of it is for it to be more decentralized. Could you maybe talk about that a little bit?
Right. So as of soon, the Near network will be operated by a set of block producers which in no way are involved with Near Foundation, right? And so at that point, Near Foundation can mostly recommend what to do, but not impose anything. Near Foundation has certain number of tokens which they will have that they can use for development of the protocol, and in particular, most of the development will be coming from Near Inc., which is a San Francisco-based company. But again, Near Inc. has zero power over the network. So for as long as what we do favors the network, it is expected that the block producers will be adopting our changes. So that particular form of governance is already implemented. The way it works is that once if we ship new version and the block producers decide to adopt it and they reboot their networks to run on the new version, on the network level, the nodes constantly exchange which version they support. And if at the end of a particular epoch, more than 80% of participants are in favor of a particular version which is different from the current, the network will switch to that version and will continue operating on it. Besides that, at this point, there is no plan to implement any sort of more involved governance. So nothing like Tezos or Polkadot, primarily because it's unclear if that's needed. Right, so most of the governance can be carried out through what I just described, but also so far it is unclear if those sorts of governance work, and the stakes are too high to have them on the layer 1 level.
Okay, a question a little more directed at Peter. Could you possibly maybe just explain a little bit of the future more generally, like I know it's kind of open-ended, but just what goals do you have next after, you get the main net more stable, and just future plans for Near?
Sure. I mean, I'm sure Alex could comment on that too, but
Yeah.
Fundamentally, more decentralization and more community-run initiatives. So, for instance, I mentioned before we started broadcasting to people that we've condensed our community programs. We had a bunch of them into one thing that runs through a series of guilds. The goal is to actually scale these past like Near Inc. Near Inc. is just the provider of example code technically, and then Near Foundation is the provider of funds for people to do stuff on the network. So not just theoretically now, but really tangibly, we want more people in the ecosystem to start building things. I'm really excited actually. There's going to be, so we have this JavaScript API. Somebody built one in Elixir because they're trying to launch a business on top of Near, right? They're trying to launch an actual company. So things like that are coming down the road. There's also a bridge that's going to be fully functional very soon between Ethereum and Near. And then the community goal overall, the thing that's kind of a rallying cry is 1 million active community members in the Near collective overall, which is like pretty loosely defined. Like there's a guild for fashion and crypto, and there's a guild right now for multimedia, stuff like that. So that's more of that on the roadmap, more community run stuff, more decentralized, more permissionless, all of the good stuff we like about crypto.
Awesome. And Alex, do you have any general goals in your mind for Near? What do you see the future of Near to be?
So I think long term, one of the there are multiple goals where I would like to see Near making change. Generally, one of the biggest driving factors for me why I started Near at all, and why many people joined Near, is this effort called Open Web, where we want to be building services which are operated by community and not by centralized oligopolies. Blockchain is just a small building block there, but blockchain is necessary. It is necessary for identity. It is necessary for orchestrating, for example, storage providers, compute providers, etc. With the higher focus on blockchain, one of the areas where I really want Near to see making huge change is what we call ownership economy, effectively building services where either marketplaces or services such as DoorDash or Uber, where the service is not owned again by the company but owned by actual participants. What they decide the governance, they decide how the service develops. Obviously, they're not building it, but they are making all the major decisions and distributing the resources. But also they building it in a way that benefits them and not the profit-seeking entity behind it. So far, it appears that short-term ownership economy will be is going to be succeeding in the space of decentralized finance, right? So if you think of Compound is an example of an ownership economy, and so short-term, I think Near will be making certain efforts to make those services, to benefit those services, right? So provide them with better usability for end users, with better scalability, etc., lower prices.
Okay, yeah, thank you. Switching gears a little bit, I'm going to start asking some of the Q&A questions people have asked in the chat. So the most popular question right now is someone asked, could you maybe touch on the coexistence with Ethereum and IPFS? So in terms of IPFS, I think all the protocols can coexist with IPFS. We don't have a bridge per se with IPFS, but once it comes to storage, the bridge usually does not need to be bidirectional. You primarily need the bridge from the storage provider to the Near. Effectively, you need to prove that something is stored. Okay.
But you rarely need to prove to IPFS something that happened to Near. We don't have the bridge with IPFS today, but that is most certainly feasible.
Lots of people, just to add to that, lots and lots of people have used IPFS for storage and hackathons. So there's plenty of examples out there on GitHub of people who have actually already interacted with IPFS. Yeah, no official bridge, no official SDK right now.
Right. Yeah.
It's been done.
Yes, for many practical use cases, you actually don't need to prove. Yeah, Peter is right that if you're building a user-facing application, you actually don't care if Near knows about something being stored, right? It just needs to be stored. So in this regard, IPFS or RV for Saya, we're trying to be friends with all of them, and When it comes to Ethereum, the integration is way more deep because in any foreseeable future, most of the assets are going to be on Ethereum. There's a huge number of assets which are Ethereum born, right? So trying to overtake Ethereum is probably impossible in any foreseeable future, but also it's not the goal. The goal is to build something for the community. So the goal is to build bridges, not to try to conquer anything. So we have built a bidirectional bridge with Ethereum, which is as secure as it gets. So the way the bridge works is that it runs light clients as a contract on both sides. So on the Ethereum side, we have a light client of Near implemented as a contract. On the Near side, we have a light client of Ethereum implemented as a contract. And so therefore, as long as, so from Ethereum side, the light client guarantee is obviously lower than the full node guarantee. The light client guarantee says, so full node says the transaction is final unless there is someone controls more than 50% of hash power. With the light client, there are more possible attacks. For example, you can eclipse Near node, right? You can not submit something from the main chain and submit something from the chain with invalid state transition. But in general, it is extremely secure, and it is extremely generic in the sense that it's not just asset transfer. You can prove arbitrary statement about anything on Near and arbitrary statement about anything on Ethereum. So you can prove existence of any transaction, existence of any receipt, existence of any log entry, existence of anything in the state, etc. Right, and therefore you can create arbitrary communications. So to an extent that it is not built yet, but it is possible on this bridge to build cross-contract calls from a contract on Ethereum to a contract on Near, and then a callback on Ethereum side again, etc. Right, so you can think of Near as extending Ethereum ecosystem by providing fully within the ecosystem. There's another runtime where you can with lower fees execute with slightly different account model, execute transactions and then go back and forth.
Okay, yeah. Kind of adding on to the idea of verification. When we were talking about IPFS, one of the questions was, does Near's current sharding architecture prevent the implementation of zero-knowledge proofs, or can zero-knowledge proofs be added into the system?
So zero-knowledge proofs depends for what, right? So the question is, in general, is it possible to implement zero-knowledge proofs on Near? It is somewhat orthogonal to sharding, right? And zero-knowledge proofs are possible to implement on Near. We have precompiles for the BN curve. We will have precompiles for BLS curve. And for example, zero pool already exists as a pull request against Near, so you can, once it lands, you can have private transactions on Near. So there's no problem with that. I assume the question could have specifically been referring to whether it's possible to use zero-knowledge proofs to compress the Near chain. That is not viable in any foreseeable future because Near uses arbitrary state transitions, and zero-knowledge proofs for arbitrary state transitions are possible, what is called ZEXI. I'm not sure how it's pronounced, but they're extremely slow. So that is not something that we're looking into, and we don't plan to implement it.
Yeah, this is just maybe a more general question for both you guys, but can you comment on the recent Near token sale, if you can?
Peter, would you like to take this one? I would prefer not to.
Sure. So, I can't say much, but I can tell you some of the facts, which I think everyone might already know. But essentially, we had allocated 10% of our total network, which is 100 million tokens, and we had thought that was going to sell over the course of 7 days, and it all sold within 2 hours, which is great when you think about it in the abstract. That's great. There's a lot of demand for this token. A lot of people believe in this network. The hard part, the part that's for my I guess you could say my day job, makes it really hard, is a lot of people in Discord reaching out to me individually saying things like, hey, I've been a part of this community for a while and I didn't get a chance to buy the token. I didn't get a chance to put, my sort of my money where my passion is. That's the more positive version of a lot of the messages. Got an announcement about extending the event. I think maybe we're running out of time or something. But that's about as much as I can say. I can also say this, which is that this is just 10% of the allocation of total token distribution. There are many more tokens that we're going to be distributing to people through contributions, through community initiatives, and I actually think it's a better way to distribute tokens, especially to developers. And this is a developer-centric sort of meetup. So if you are a developer and you're interested in contributing because you want to get tokens via that way rather than just going and buying them before we launch phase 2 mainnet, where I'm sure they'll be on exchanges, the best way to do it is to go through our community program. So if you go through the guild program, I mean, it's not even the guild program. Just go and join our community. There's lots of opportunities. There's also bounties that are already published with dollar amounts associated with things that you can actually build. So that kind of addresses, I don't know, some questions people have had about the token sale, and that's probably legally more than I can say, but that's what I can say.
Okay, yeah, thanks. Just another general question we've had. Do you guys have a bounty program? Do you have any bounties currently out?
Yep. So there's like 3 places you can see bounties. I mean, if you're on GitHub, that's the easiest one. Is there's a repo that actually I maintain. So don't text me right afterwards if there's problems with it. But you can see bounties as issues created, and also we really encourage if you have a crazy idea that you want to see. I'll put this in the chat, by the way.
Yeah, awesome.
Yeah. So general thoughts. Here's the link. Yep. There you go. Yeah, thanks Alex for dropping in the token supply and distribution thing. That's actually really worth a read. The bounty's right here. If you have some crazy idea, submit it as a bounty, and then I will actually put a price that I think would be fair to pay out for it. So these can be community generated as well. Yeah. So like one that I was really excited about is like a layer on top of community, similar to Reddit, where you could get some community coin for any arbitrary community. That's actually a really good blockchain application. So
awesome. A little bit more back to sharding, but could you maybe explain, Alex, how Near's could upgrade its sharding protocol in the future?
So I'm not muted, right? Yeah. So the protocol is described for upgradability when 80% participants can vote for the new version.
Okay.
So that allows you to change protocol in arbitrary ways. So the way Near in general built is that every version can speak to itself and the version that immediately precedes it, right? So once the new version is shipped, but other than that, it can implement arbitrary changes, right? So it can completely change the way sharding works. It completely change the way protocol works, and it's the community of people who run the blockchain who decides. And if they decide something that the rest of the community doesn't like, well, the rest of the community still has the social consensus, right? They can always say, well, we're not going to be respecting this change. We're going to hard fork. So social consensus is the ultimate way that blockchains are maintained. So specifically for sharding, there are a couple other aspects which are related to your question. One aspect is in sharding, something we did not touch on, but shards can get congested, right? So one shard can become more popular than another shard, short-term or medium-term. So we don't have it yet, but we are building a feature so everything is designed in the way that it is implementable, called dynamic resharding, where between 2 epochs, the boundaries of the shards can shift, right? And so if a particular shard is congested, the boundaries will shift. The same feature can spin up new shards or shut down all shards if the load is not sufficient. I guess the latter is not needed. So we don't need to use, so short term, most of that will be happening through the on-chain upgrades, right? So if the number of shards become insufficient, we will increase it using this 80% vote. But longer term, it will be happening. It will be happening through the dynamic resharding. So the spec for the dynamic resharding is not on the GitHub. However, most of the things like that are being discussed on. Will be discussed on the. Actually, it was discussed on a particular research meeting, which we were hosting on Tuesdays. We're still hosting on Tuesdays chain sync meetings. This one might not be uploaded to YouTube, but I can make sure it is uploaded.
Yeah.
And yeah.
Just another maybe more general question. This wasn't Q&A, but I think this is a good thing to discuss real fast. Could you maybe guys explain a little bit the current state of the mainnet right now? I know you're doing a slowly transitioning in and just the plans for the next month or so. Right.
So we roll out mainnet in 3 phases. They're called phase 0, phase 1, and phase 2. So phase 0 is effectively it is mainnet in quotes because we completely operate it and nobody has any near tokens. And so but applications who want to build a near, they can reach out to us. They can get deployed. So the goal for mainnet phase 0 is to create a genesis. So the genesis is created. If an application deploys to this network, they can be certain that whatever state they create will remain when the mainnet becomes decentralized. So they can start onboarding users. They can start building up their application. Nobody is live yet, but we have multiple projects which are going to be going live in the course of next 4 weeks to 8 weeks.
Okay.
Then mainnet phase 1 is different from phase 0 in that we do not control a majority of the staking power, and I would not be able to say how much we're going to be controlling, but it's going to be way less than 33%. And so therefore, it is at that point it is decentralized, but the near is still not transferable. So most of the near that is staked is locked only for staking, and the rest of the near is not assigned yet. And then phase 2 is full mainnet is when near tokens are provided. And so transition from phase 0 to phase 1 is going to be orchestrated still by us because we control the network. So we're going to onboard the validators. They're constantly running a testnet, a beta net, which is fully decentralized. And so once we feel that it's sufficiently stable, we will onboard them. Transition from phase 1 to phase 2, it is not driven by us. It is the block producers themselves. At some point, they vote using this 80% vote that the network is ready to have near allocated. And effectively, that will be after a short period of time after phase 1 is launched, after they make sure that the network is operational, that their hardware is working. And most of those block producers, as of today, are going to be professional block producers. Same people who run Cosmos, same people who run Polkadot. Okay. Primarily because very few people in the community besides them actually know how to operate blockchain networks. But they will be using tokens delegated to them from the community at large, right? And so those delegated tokens can vote them out, right? So if one of them starts behaving weirdly, like skipping blocks, censoring transactions, the tokens will get delegated to others, and most likely they will get they will not meet the threshold to get to top. Whatever, I think it's 100 of block producers.
Okay. Yeah, that definitely helps. Like lay the roadmap out, see where you're planning to go, and just the steps. Another question from the Q&A. This is probably more focused at Peter, but someone asked, since BAF is centered around students, could you talk about any career opportunities for younger developers?
Sure. There's two forks here. One is actually like working for Near Inc. But like as we progress forward, I think that is going to be maybe like less attractive than the alternative, which is working inside of the community. So I think within a relatively short period of time, there's going to be, so for one, people building on top of Near are going to be hiring really soon. I think several of them are. I don't know if I don't know if they're publicly posting this yet, but that just keep your news feed, keep tuned to Near's Twitter, for instance. We'll probably retweet those. So some partners are going to be hiring. That's one way to get into the ecosystem. The other thing I said earlier is this guild program, this bounty program. I wouldn't be how to put this without like over promising. It's sort of like, I think there's a future in which you can become a core contributor without getting a job at Near Inc. And I actually think it's a really viable career path. And if people are interested in doing that, just reach out to me directly. That's actually fine. My email is peter@near.org, and I can kind of help you navigate that. On top of that, though, just some broader advice for students who are starting their careers. This is just kind of more generic advice. Just like keep building stuff. If you're a developer, if you're a designer, just keep designing stuff, keep making things. Not just for a portfolio, but like if we are sitting down to hire somebody, what we look at is what have they built, what have they done in the past. So that's also a great way to move forward. And then, working at Near Inc., of course, is like a viable path as well. But it's like, the bar is very, very high, and we don't really hire junior engineers right now. We probably will in the future, but we just haven't historically had the bandwidth to support people as junior engineers. It's just we've just been moving too fast and keeping things really scrappy. So that'll probably change in the future, though.
Yeah.
There's a link also in the chat from Cameron. Open Web Collective is an effort within Near. So if you feel adventurous and you actually want to start a company which runs, not necessarily on top of Near, I don't think Open Web Collective is Near specific. You can join our Open Web Collective, and there's a lot of resources and a lot of mentors and a lot of people who will be helping you with building the company.
Yeah, actually, thanks, Alex. The #1 recommendation is please start a company. I mean, like, oh my gosh, what a good time to start a blockchain company. Like, if you guys are here in this room, or metaphorical room, you're at the bleeding edge of blockchain right now. So you'd be amazed at what knowledge you have that people outside of the space don't have right now. So you're in sort of a good position.
And just to build on that, not only are you here, but you're here with a bunch of other builders who are also eager to build things. So that kind of leads us to sort of the conclusion. And I just want to thank Alexander and Peter and Colin so much for doing this.
Yeah, thank you guys.
Incredibly helpful. We've recorded everything. We'll put it up on YouTube after. And kind of building on top of getting more connected to the other members of the community, we have this membership application that we sort of use as sort of a proof of work. It's completely free to become a member of BAF, but we want to make sure that everyone involved is actually interested and is not just going to join our channels and kind of pump a bunch of stuff that isn't very I guess conducive for growing the ecosystem. So I'm dropping a ton of links, and that's not very well formatted. Ton of links in the chat. First one is our BAF membership application. It's completely free. It's for everybody. So everyone who is, you could also share this with anyone else who's interested in getting more involved. We're also starting a course at UC Davis. So as mentioned earlier, we started accredited courses. This one, we very strategically negotiate with the Department of Engineering to open source it, which is very exciting. And we're actually I wanted to talk to Alexander and Peter, probably email you tomorrow about teaching at, a lecture of this course, because that'd be very cool. And besides that, if you're not in university right now, there is a open consensus. I'm sorry if there's a conflict of interest here, but just trying to get more people involved in the space generally. A free course that is available to the public right now. It's actually paid. We have some scholarships available. So I'd recommend you checking that out and applying. And then next week we have 2 events. One, the blockchain in Africa, where we'll be diving into the education, development, and adoption of the state of it all of in Africa. And then later on is an event with Gitcoin and Panvala. Drop those links there. And if everyone can right now also take the SHE-256, not a Satoshi, SHE-256 diversity survey, that'd be great. Trying to increase more diversity in the space. And if you've enjoyed this event and want to support future events, you could donate to the Blockchain Acceleration Foundation. Everything that we have done has been completely volunteer. Everyone who works with us doesn't get paid. I even couch surfed around California for a year to put all this together, and PG and I work super hard on hosting these weekly events. So if you've enjoyed these events, please donate there, and hope to see you next time. And thanks again, Alexander and Peter and Colin. We'll be entering the networking portion, and hope to stick around, everybody. Talk to you soon.
Yeah. Thanks for hosting. Thanks, guys.
Thanks, everyone.
Bye.